term called environments. So why this environments is utilized? Because we'll just base root there. I can create the environment here. Softwares or libraries particularly suitable for the project. For example, let us say I've been working on the blockchain. Where do I just go for it and I just install on the base root will have the up to date libraries which may not compatible softwares, because every time you cannot remove it, you cannot uninstall it again. So instead of that, what we can do here is create an environmental variable. You can create your own environments variable, and from the environment applications, you can do some applications over here. So that is the logic which you have to create over the mechanism. So that is the mechanism which we have to create. That is the will prevent the conflicts between the softwares, will prevent the the environmental variables. Please remember, when you have different softwares and for example, you may use a Python 3.0, something else for Python 2.7. Compatible projects or need to be utilized only by creating the environment so that it will not disturb the other thing. If this base root is being updated with the sky, creating the new environmental variable where you can install your own software for this logic. Start doing any project, just list out all the libraries compatible for writing a code. Creating the environment with nothing else plus create. That's all. Once you press create, it will create the environmental variable for a kind of this mechanism. So whichever the environmentals are selected, there will be selected, and here you have a lot of. So that will be the useful for you, or you can go for a spider. So out your online, but Jupyter, you need an online thing. That's in a web-based interactive section. So that has to be done over here. Now I'll go for it. After clicking on Jupyter, I'll just go for it. Hopefully you can see the code, right? So can everyone can see the code, right? Anything. So new notebook, you can create your own new notebook through this, and you can start doing your own here. So you can create your own. So I'll just make it in this cases. So you can I'll do one thing. Environment, I'll just copy on the separate notebook. So every classifies and everything. Annually about the performance metrics. We have receiver operator characteristics, which is we normally utilize to find out the stability of that is the most utilize Keras for forming at NN, because that code consists of all the models in single file. So which I told you, and from the tree we have given from the decision tree model, and the most important thing which we talked about is and then boosted classifier, which we have discussed on the morning. So and SVM. So there will be a cases over here. So this is a logic which we have to understand. So I'll share this code so that it can. This is the data set. So own my mechanism, that is I have my own library or directory which I have stored all thousands of data sets are available. So from the thousands of data sets, it has been given over this kind of application. So the help of it, we can go for an application. So first load the data, and all the data is in CSV format. If it is in Excel, and then you have to go for this file, changes of your file. So what things you want to do it? What is so the PD will have all data which is required, and this all this data can be done into an application. So please, this is the thing, pd.read. Now the data sets will have all the data will one kind. So this is the logic which we have to take over, and this is all for the visualization of the codes. So visualization of the decision, not worry about it. So next is something else we have to take over here. So as with the steps, the data set is all about the diabetic data. I'll show you the data. So it is all be like it is data later on. So now the data set is being, it is having a 9 columns actually. It is having a 9 your output. That is the label. right? So that is the label we have. So now this data set the 9th column as the output. So as we told about, I show the data set, you can understand here. So you have to see the data up to which take the mechanism. So that is the logic which you have to understand clearly. So this I location is utilized to store your data, that is your separate your has been separated, and from that we are going to separate the input and output. From that we are going to have a separation. This is the logic, training and testing separation. Okay, training and testing. That means the training data is 70%, that is 0.7, and the test data is 0.3, that is 30. More number of training should be allocated. More number of data should be allocated to the training. To your testing data, and remaining data is your 0.7. It is the 0.7 data which comes into the picture. This is the these are the model separations which we talked about. Now I'll come to these cases which we have discussed. Random forest classifier, right? All these things, all these models have the things you have to change here is I'll just explain you with one single example. Random forest is 100. So can you tell me what will be the estimators is all about? If you work on this, if you are not being very strong, or we cannot alter the code according to our applications. We cannot alter the code according to our application. It will be a simple line of codes to write it without knowing the number of trees which is required, the number of trees which is required with the voting. So that is that the trees of 100, and from the vote, with the help of a voting, it takes the best out of the result. This is the logic. Once you any value for getting the best results. So this is the one thing. Once the classifier is called out, now next classifier what we talked about here. So you can see this. What is this? What we have combined. As morning I have told you about this classifier. classifier is all about and what is this all mentioned here. Please come out with the answers and even think about what I talked about. So please think about the answers and just please come out. Classifier, or how the voting classifier works. Can anyone just make it out in a message? Please tell me like what is voting classifier is all about. It's a type of, we talked about ensemble actually. So here in the morning we talked about, right, the voting classifier. This is logistic regression. This is random forest, and this is SVM. Hard decision is taken, right? Hard, it will be making out the complete checking of every algorithms, and it won't leave even a concern. It will round off and it will identify it. So better to use hard for the voting because it takes the combines the three values, right? I have called the three values: regression model, random forest, and SVM. Now my will be, if you don't know the model which can be suitable for this, you can go for a voting classifier. Combine everything, not a combining, take model separately, put it for the voting class, will be taken into an account for the final output. So it is, this is the model which is having a voting classifier. This is the model which is have the voting classifier. If I dot add the dot fit train, and then I'm using for the prediction. I'm it is utilized for the prediction with the test values and identifying the. But when you don't understand the concept, we cannot able to make it as a model. This is the primary criteria voting classifier we talked about. I'll just show you another thing, another code of line. I'll show you another code. Can anyone tell me the difference between these two? What is it happening? And here I have just made some other algorithm. So can you tell me what is this? Morning we saw that what is the case actually. What about this? What is exactly all about? The name itself indicates what is there actually. Name itself indicates what is that, what it does. Pardon, regression. But in the morning, I told you with the boosting, ADA boost classifier. That
Boost
is,
classifier, yes.
yes, the logistic in the voting, I told you like three or more algorithms are not combined. Based on the three algorithms, it takes the best result for the output. But here, boosted with that. So that is why I told you are being boosted to get the best performances. This is how the ADA boost classifiers are being utilized, or the what we have, combining with the model what we have. So based on that only, it is being decided for an application. Understand? So the coding, you can do it very simple. Until otherwise, we can't understand. If you don't understand the again, I'll share even another code. Please answer my question actually. OT. Can you identify this code actually? Can you tell me? And hidden layers is 10, right? Hidden layer size is 10 layers are utilized for this data. Example, when I want to boost the data, so what I can, we call this an FDP here. So I'll just make it ADA boost. So when you want This is logistics boosted. Actually, if you want to have a morning session like boosting neural network, so what we can tell you. What I can do right now is call this. That is what is you call as MLP classifier hidden states. Let us like taking the random data. It is not what is it? This is the case, right? So this is the logic of boost. Now my a model called boosted neural network. When the votings are concerned, we cannot work only with this single model. You have to combine more than one. That is minimum two, actually. So that is the logic which we have to take over this. Here, this is the model which we have made it, and now the model which the FDP has its FDP dot fit. This is the logic. So FDP dot fit. That is what you have train of x and train of y. So the x and y is predicted. So now we have to classify this. So now what I can do is FDP model equal to FDP has been now trained with the data. It has been FDP. This variable consists of with the trained data. So this is the logic which we have to understand. And after that, this model is utilized to predict. So y output is equal to test data has to be made. Now it tests, and then you have y test. This is your actual output. Y test output, we will design the accuracies. The 5 parameters which we called as accuracies. So this is the logic which we have, and we have a lot of parameters which is been dealing with the steps blue using your confusion matrix. C curves can be utilized to make it. Confusion matrix is something like we can draw it. And similarly, we have this matrix can be drawn with the help of a Scikit library where it can able to use for an application. So this is how the logic works on, right? Now, right, so the best performances, that is what we designed right now. What we call this boosted neural network data sets. Right, so now this model has to be tested. So where do I test it? Actually, this is where we lag. Actually, deploy this model, where do I make it out here? So all the models are ready, we are getting a 99 most important because we don't concentrate on the deployment stage. We don't concentrate on the deployment stage. So this is the logic which we need to understand clearly. So this is the logic which need to understand clearly about this mechanism. So this is the logic which we have to understand. So this need to take over this concepts, right? So pickle file has to be deployed. Conversion of this pickle file. Where do I deploy it? In the PC itself or in the cloud? Can be accessed through mobile app. So this is the logic. So when you develop some projects, so deploy it in the cloud. Deploy it majorly in the cloud. So the clouds may be having this kind of application that is like AWS systems, Amazon Web Services, and from that it can be deployed in the mobile app solution. It can be deployed in inputs to from the mobile app, giving the outputs can be visualized in the mobile app itself. Be done over here. So inputs from the mobile app due to the cloud as a, because it will take time for converting to a pickle file. So deploy it in the deploy it in the cloud and see the output in the mobile app. This is software centric. This is software centric outputs which we have. Then we have another process which we called as a hardware centric. We can deploy it in the hardware also. So what are the hardwares which is suitable for doing this pickle file? Yes. Which can primarily act as the edge devices. So hardware is like what the edge devices, and most importantly, advanced FPGAs. We can do it in kind of advanced FPGAs, and the most preferably uses nowadays we have libraries, the pink version boards. So this is all the things, and we have an for this you can use this called Xilinx utilized for the deployment in the hardware. So this can be deployed in the hardware, and this can be deployed in the cloud where you can see the inputs. So same procedure. The hardware will have the inputs. You can give the input to the hardware and see what is happening, and the output can be obtained in the hardware also. So this is a logic which is being integrated in the deployment stage. So deployment stage, after finding out the model, after finding out the performances and everything, you have to make it course. And if it is hardware, go for this GPUs and FPGAs. And this for this kind of FPGAs, you have this libraries which is already there. And for the GPUs, you can use Anaconda itself. It is not a big issue, big deal. It can use the Anaconda itself to run the show on this. So this is how the deployment ends, and this is your end of the cycle for the deployment. So see, like you need to understand. So this is how we have gone for the first we learn to understand the logic, understand the concept behind the algorithm. Data sets, whether it is blueprint, what I have shown. Simple. If you do this, simple, you can, after doing a different categories of logic, you can understand this can make you, or this can make a better mechanism over here. This is the complete cycle which we have to take care. And I have a codes, and I'll share the codes with you so that you can also practice that. The codes, the softwares also, I told you what is the significant like a new one. The deployment, we never concentrate on it. Kindly concentrate on the sections. This is most important. The steps for converting for the deployment, I already talked about. We already made this. So kindly follow this. If this has been followed, then you can make it for the solution. Right. Any doubts, guys? These things are clear actually. The things are clear actually. Guys, it's clear what is what actually. Actually, right? So now this thank you and for this session, and hopefully, if time permits, we can meet you again for a more number of practical things which we can do for hands-on experiences. Okay, thank you and best wishes.